Good morning. Uh, we have discussed about different types of summer air conditioning systems in the previous class, and based on that, I have given you one numerical problem in which the indoor conditions were maintained at 25 degrees Celsius, and I have written it wrongly. WI, it should be phi I, relative humidity, because it's in percentage, so it is nothing but my relative humidity. It is not basically the absolute value of humidity. Okay, and the room sensible heat load was 100 kilowatt and room latent heat load was 20 kilowatt. There were two parts. In the first part, we need to calculate minimum volume flow rate. Okay, what will be the minimum volume flow rate? And in second, in this question only, we also need to calculate volume flow rates of supply air if the temperature of the exit temperature of the supply air is 14 degrees Celsius, 15 degrees Celsius and 16 degrees Celsius. Okay, and then if we consider x equal to 0.15, what is x? Bypass factor. So if bypass factor is 0.15, then what will be supply air state and the volume flow rate? Okay. So any of you have tried this question? Anyone give a try? No? Okay, so let's discuss. Tell me how to proceed. How we can proceed for the first part? How I can go ahead? So you see, in the initial condition, what is given? Ti is given as 25 degrees Celsius and RH, which typically I am calling phi I, it is given as 50%. Okay. So these two conditions are. RH is 25 also. Okay. Let me check actually. I think it's 50%. Okay. So did you try this question? Solved?
सर एक जगह दिक्कत आ रही है साइकोमेट्रिक चार्ज में और आरएसए जब फैक्टर से बनाते हैं तो 0.833 आ रहा है आरएसए लेवल का तो सर जो ऊपर काइंड ऑफ प्रोटेक्टर दिया हुआ है उससे मैंने बनाया है तो मेरा टेम्परेचर 20 आ रहा है 20 से ज़्यादा
ये सर वो सर्कल से देखना नहीं आता है
Okay. So you are finding difficulty. Let's see. So I'll show you first one method. Here we will try to do it without even plotting the processes on the psychometric chart. Of course, for obtaining certain properties, we require psychometric chart. But let us attempt first to do it without that. Okay. So first, what we have the indoor condition as 25 degrees Celsius and 50% RH. Okay, so what I can do, if I have to calculate specific humidity WI, what I need to do? Please tell me. This we have done earlier also. If temperature is given and I need to calculate WI, how we do calculate?
0.622 into 5 p upon p minus pa.
Yes. First we will be going to, so if you see the formula for WI, it is nothing but 0.622 into PW upon P minus PW. That is the formula. Now, what is given? Phi I is given, and other thing is given as 25 degrees Celsius. So what I can do? I have discussed this with the previous problems. I don't know why you are not telling me. So at 25 degrees Celsius, I will be calculating saturation pressure. So PWS will be P sat at
25.
how much it is? This I will be calculating from where? From steam table. Okay. So you have to understand, whenever we are dealing with moist air, sometimes you may have to refer to steam table. Sometimes you may have to refer to psychometric chart. And if it is given in the question that you have to also say design the refrigerating system, say mass flow rate of refrigerant through the cooling coil or so, then whatever refrigerant is given, you also may have to refer to the refrigeration charts or tables. Okay, so that's why clarity should be there for which parameter, which type of table or chart will be required. Okay, so because I am trying to measure the saturation pressure of the water vapor, so saturation pressure is nothing but equal to P sat at the given temperature, so at 25 degrees Celsius. And if you calculate this value from the steam table, it comes out to be 0.031693 bar. Okay, now we know that Pw, which is partial pressure of the water vapor, okay, this is nothing but equal to 5 times of PWS. This thing is already we have studied. So if I now make the substitution over here, I will be getting that Wi is equal to 0.00988. All are clear with this? Everyone has got this one? Okay. Now what I need to do? After this, what I can do? After this, the easiest step is RSH is given as 100 kilowatt and RLH is given as, can I calculate RSHF? Can I calculate RSHF? So RSHF will be nothing but RSH divided by RSH plus RLH, 100 divided by 100 plus 20. How much it is? 0.83. So I have got the RSHF value. Okay, and it is given in the question that there is no information about the ventilation of the air. Okay, in this particular question we do not have any information about the ventilation. If we do not have information about ventilation, what we will be having? I will be having the entire room sensible load and room latent load acting on the cooling coil only. Okay, so it means that if I represent this process on psychometric chart, what I will be having? Please tell me. I do not have any ventilation. So outdoor condition will not come into picture. Only thing I will be having my indoor condition, because I am not allowing any outdoor air to mix. Only room air is being circulated. So indoor condition means state I. After that, what I have calculated? RSHF I have calculated. So I can use the scale of sensible heat factor and then alignment circle. From this I will be getting one line. Okay, now I need to draw a line parallel to this line. So if I draw a line parallel to this line such that it is passing through point I. Is this point clear? Such that it is passing through point I will be getting this line as nothing but my RSHF line. Is this point clear? Wherever RSHF line on the psychometric chart is meeting the saturated curve, corresponding to that, what I will be having? This will be my TADP, apparatus dew point temperature. Is this point clear? If you use psychometric chart, you will be finding that the value of apparatus dew point temperature comes out to be how much? You are getting 20. Actual value should be 12.2 degrees Celsius. All of you please bring psychometric chart in the next class. Okay, so take a print of the psychometric chart, whatever psychometric chart you are getting, Some of you may get psychometric chart where you will be having SHF scale over here. Some of you may get psychometric chart where you will be having some protector over here to mark the different values of SHF. So when you used this one, what you need to do, with reference to this point, you will be getting a value of somewhere over here. Did you use this side or this side? This one. Okay, because the process is cooling and dehumidification. When process is cooling and dehumidification, we have to use this type of line. When process is heating and dehumidification, then I may have to go for this one. Is this point clear? So the process, nature of the process is this side. So what I need to do, if I see here, what value you will be getting? 1
Angle
on the psychometric chart? Yes.
173.
173. Okay. How you can calculate the angle now? Please tell me. For protector, if you have protector, how you can calculate angle?
Reference point.
If you know the RSHF, how you can calculate angle? Because in this protector, if say angle value is given, it is not given what is, because some of the psychometric chart, what they do, let me clarify to you. Some of the psychometric chart directly will be giving the scale from say 0 to 1. Okay. So in this case, what will be happening? Depending upon the given value of the RSHF, which is 0.833. You can take that value and you can draw a line parallel to that line. Is this one clear? But in certain cases, instead of the direct value of the SHF, you may have the value of angle over here, theta. How to calculate theta? In one of the previous lecture we have done tan theta equal to, what was tan theta? Delta W by delta T, which represents the slope of the line, and slope of the line was nothing but 1 divided by 1 plus sorry, yeah, 1 plus 0.2451 into not this one, it was like this. RSHF, room sensible heat factor, is equal to 1 divided by 1 plus 0.2451 into tan theta, delta W by delta T, which was nothing but equal to tan. All are having this formula or not? Please understand this point very, very carefully, and in the next class, which will be on when? Tomorrow is no instruction day, so we will be having class on Saturday. In Saturday's class, please bring, all of you, please bring the hard copy of the chart, because
सर ये जो है इसमें एक सेंसिबल हीट डायरेक्ट दी हुई है या फिर रेशियो दिया हुआ है ये आईडी दिल्ली वाला है
this is sensible heat by total RSHF, direct load.
डायरेक्ट वैल्यू
Is this one clear? So 3 types of psychometric charts you will be getting. In one, SHF scale will be over here, where you have to use alignment circle and SHF. Okay. Second, you will be having one protector over here, and on this protector, the values marked will be nothing but ratio of sensible heat by total heat. If value is simply given sensible heat by total heat, it means directly RSHF is given. On the other hand, in certain charts, you may have over here value of theta. So if the value of theta is there, then first RSHF, using this formula, you need to convert into theta. Okay. RSHF you have calculated, then you need to convert into theta, and then that particular value of theta you will be selecting over here for your actual process. Is this point clear or not? All of you are understanding? So say the ratio of SH by TH is given, then somewhere over here you will be getting value as 0.833. So parallel to this you need to pass line such that it is passing through your indoor point. All are clear with this point? So it means that if I have to use psychometric chart, then calculation of TADP is very simple. You only need to first calculate RSHF, and after the RSHF what you have done? You have passed located state I and you have passed the line parallel to RSHF line. So, and when this line is intersecting the saturated curve, corresponding to that whatever temperature is there, that is your apparatus dew point temperature. All are clear with this point or not? Please tell me. If I do not have psychometric chart or I have to do it manually, how I can do it manually? Using equations, not graphically, but I need to use analytically. How I can do it? What is my RSH equation? Please tell me. RSH says 0.0204 QVS recirculated air into TI minus, correct? Then another equation I will be having RLH. RLH will say 50 times QVS into WI minus W8. All are clear with this point? Now the ratio of RSH by RLH can be RLH can be calculated. What is this ratio? 100 by 20, and this will be equal to, if you do calculate 0.0204, QVS will be cancelling out. TI minus TADP divided by 50 into WI minus WAD. All are clear with this point? So from this ratio I have come with a single equation, and the equation is TI minus TADP equal to 250 into WI minus WAD. This is a single equation. How many unknowns? Two unknowns. ADP and WADP are unknowns. Okay, now what I need to do then? I need to do iteration, because both the unknowns are interdependent. Okay, so let me initially choose that I have assumed TADP is equal to 12 degrees Celsius. If I assumed this as 12 degrees Celsius, corresponding to this I will be able to calculate the WS 0.0. What
divided.
Okay, you are saying no. I think this is the after doing all multiplications.
250 to pहले
5,000. See, 50 into 100 will become 5,000. It will be okay. 250 divided by, yes, correct, 0.0204. Fine. All are clear with this point? So now if I assume ADP equal to 12 degrees Celsius, corresponding to this ADP, I can calculate WS. How I can calculate? I will go to psychometric chart. I will choose from here value of how much? 12 degrees Celsius, and then from here I will take a vertical line which is crossing the saturated curve. From the saturated curve I will draw a horizontal line, and from here I will be noting down the value of W. That will be my corresponding value of W ADP. Is this point clear? Okay, when 12 degrees Celsius is there, then ADP is 0.008766. Process is clear. Analytically, if I have to do, I don't go for drawing the RSHF line. Okay, then how I am trying? First, I assumed 12 degrees Celsius. But when I will be substituting 12, I also need WADP. For calculating WADP, what I will be doing, on this plot, I will be going to 12 degrees Celsius. From there, I will take a vertical line which is crossing the saturated curve. Corresponding to saturated curve, I will be reading the value from the specific humidity, and that will be giving me the value of WADP. Clear? Now what I can do, this is my LHS, this is RHS. Okay. So if I calculate for this one, RHS comes out to be, let me give like this, RHS, LHS. RHS comes out to be 14.19 and LHS comes out to be 13.0. It means I have significant difference. My residual is not small. Okay. So if this is the case, what I need to do? Second trial, let me take second value as 13 degrees Celsius. Again, corresponding to 13, I can calculate W. That WADP is 0.00937. Let me again calculate RHS and LHS. 6.79 and 12.0. Big difference. It means my answer should be close to 12. Next value I assumed 12 point. You can take any value, 12.5, 3, or let me take 12.2 degrees Celsius. 12.2 gives you 0.008868. RHS is 12.71, LHS is 12.8. Okay, then next value is taken 12.19. Corresponding to 12.19, WS is RSH is 12.78 and 12.81. So value answer is 12.19. Now you will be telling me that it is very close 12.2 and 12.19. Okay. So if graphically you are using this particular chart for calculating the corresponding WS, then this much rounding off will be there because of the error itself. So whenever we are doing analytical method, if we have to go for 100% accuracy, then we will not refer to psychometric chart, but we will be referring to the properties of the moisture table. And in that property table of the moisture, like we have steam table and then Mollier diagram, similarly we have basically the property tables for the moisture as well. Okay, and from that property table of the moisture, corresponding to given value of ADP, I can simply calculate the value of W. So if I am referring the table, then I will be getting always the exact value. Is this one clear? From the table, I will be always be getting the exact value. So that's why whenever you are trying to do it using the analytical method, then always it is better to go for the table. Because if with analytical method you go with the psychometric chart, again you will be getting approximate value, because at least this vertical line and this horizontal line you are drawing and then reading from the chart. Okay, is this one clear? So this entire process is what? This is analytical method. As such, this is needed when very high accuracy is required. Otherwise, the approximate method you can simply go from the, not approximate exact method, but we will be doing some reading errors from the chart. So just by calculating RSHF, I can draw this, and then from here I can calculate the ADP. Is this point clear or not? Clear up to this point? Now what is given in? So it means that I have come to know about ADP. What is apparatus dew point temperature of the cooling coil? Clear? Now it is given in the first part. I need to calculate what should be the minimum flow rate of the air. How we can calculate the minimum volumetric flow rate of the recirculated air? Please tell me.
TADP.
Yes. See, when my flow is as low as possible, then entire air will be coming in contact with the cooling coil, and when it is coming in contact with the cooling coil, then the supply temperature of air will become equal to that of the ADP temperature. Is this point clear? So it means that the minimum QVS minimum can be simply written as RSH upon
0.0204
TI minus
TADP.
TADP, or RLH upon
50. But
or RTH upon HI minus H ADP, but along with 1.2, which is density. Is this point clear? 1.2 should also come here, because when I write the total load, it will be with density also will be multiplied. Is this point clear? All are clear with this or not? Okay, so tell me, what is the value of Q minimum? What is the value of Q minimum from here? Please calculate. See, I thought we will be doing many questions, but you are not responding, not at all responding, and in single question we have spent more than half hour. 382 point. Okay. And what is the unit? What will be unit? CMM, cubic meter per minute, because whenever we have derived this formula, our QVS was in CMM. Correct? Okay, so I have again made a mistake. So if it is in CMM, then this 1.2 should also have some correction factor per second. That will be in this, yeah. So per second, it means it should be
divided by 6.
Yeah, okay, because per minute, so it should be divided by 60. 1.2 by 60. How much it is coming? Please tell me. 1.2 by 60.
0.02.
Yes, correct. So this factor should be in RTH. This factor should be 0.02. Have I given this in the previous class? Correct. Okay. Now what is the next question? So this is the minimum amount of flow rate. Okay. We also need to calculate the flow rate if the supply states are,
40.
it means TS. TS is 14 degrees Celsius or 15 degrees Celsius and 16 degrees Celsius. You tell me your apparatus dew point temperature is 12 and I am hypothetically giving you the supply air state is 14, 15, 16. How this is possible? Please tell me. This is possible when I have some amount of bypass. Okay, so entire air is not coming in contact. So when bypass factor will come, then of course the recirculated air flow rate should be greater in comparison to the minimum amount of flow rate. Because when quantity of air is increased, then only the chances of bypass will be increased. Okay, so if you calculate flow rate corresponding to 14, how much it will be?
445.
QVS will be equal to again RSH upon TS minus, sorry, TI minus TS. So earlier TI minus TADP was there, now it should be TI minus TS corresponding to the supply state, and it comes out to be 445.63 cmm. So you can see the effect that when your supply temperature increased, the flow rate has increased from the minimum value. Okay. Further, if you go towards 15 degree, what it means? Flow rate should further increase. Corresponding to 15, it is 490.
490.
And corresponding to 16, it is
544.6.
544.66. Okay. What it means? It means that on this plot, this was 12, 14 will be somewhere here, 15 will be here, 16 will be here. So when you are moving more towards the room condition, then the flow rate is actually being increased. Okay, so this I have explained you while we were discussing about the simple air conditioning system, and from the numerical problem also we are able to visualize this. Is this one clear? Now what is part B?
Bypass factor is given.
It is already given in the question that I have a bypass factor of 0.15. If I have bypass factor of 0.15, then what I can do? X will be becoming nothing but equal to,
T2 minus
say T2 is my supply state, T2 minus T ADP divided by
T1 minus
TI minus TADP. Okay. Now I know TI, I know TADP, X I know.
T2 can
From here I can calculate T2. How much is T2? Supply state temperature comes out to be 14.11 degrees Celsius. Okay. Now what I need to do?
volume flow rate and sub.
Volume flow rate.
Same here.
How I can calculate? It will be coming close to
Same here.
450.
450.
Okay. Is this point clear? First part is done. Anyone is having any doubt about this problem which is on simple air conditioning system? All are fine this problem? Now let's start problem number 2, which is on summer air conditioning system but with ventilation and zero bypass factor. Okay. The room air leaves the air conditioned space at 25 degrees Celsius and 50% RH. So it means TI is 25 and RHI is 50%. Again the same conditions. Okay. And the bypass factor of the cooling coil is 0. So because I told you first we will be doing the problem with zero bypass factor. And the outdoor air is at 45 degrees Celsius and 30% RH. How much is outside temperature? 45. And RH of outside is 30%. Okay. The dehumidified air quantity is 600 cmm and 80% of, okay. So how much it is given in the question, the dehumidified air quantity, what it means? The air which we are taking from the room. Okay. So QVS is equal to 600 cmm. And 80% of this biomass is recirculated. So the amount of air which is taken from the room, out of this how much is recirculated? Only 80%. So it means recirculated air, which is QVR. QVR is nothing but equal to 0.8 times of QVS. Is this one clear? It is clearly given in the question how much we are recirculating. What it simply means, It simply means that this information is not given in the question, but from this simply we can say that QV naught, the air which is taken from the volumetric flow rate of air which is taken from the ambient, that must be equal to
0.2.
QVS minus QVR, and it will be equal to 0.2 times of QVS. This information is not there in the question. This information from our understanding we are deriving, because if out of the total air 80% is recirculated, it simply means that 20% air is fresh air taken from the ambient to meet the same amount of supply quantity. Is this point clear? Now, the apparatus dew point is 12 degrees Celsius. So, TADP is also given. It is 12 degrees Celsius. And it is asked to calculate RSH, RLH, RTH, OASH, OALH and OATH. What it means? What are all these quantities? You need to calculate all these quantities. How to proceed? How to proceed? Please tell me.
So TADP of WS tables.
First, from TADP, I need to calculate WADP. How I can calculate this WADP? Either from the table or from the psychometric chart. How from psychometric chart I can calculate this? Just now I explained. I will be going to psychometric chart, and what I will do? I will locate 12 degrees Celsius. I will take a vertical line up to saturated curve. From here I will be reading, and this will be my WADP. Okay. How much it is? Do you have tables, charts? Tell me the value. What is the value?
8.59.
0.0.
0.008.
Wait.
0.00866. 8766. Others are trying or not? Same value. Okay. Then after this, what we can calculate? Please tell me. I have indoor condition. For indoor condition, can I calculate Wi? For indoor condition, can I calculate Wi? Please tell me. How I can calculate? Again, two ways. One way is from the psychometric chart. Temperature is how much? 25. RH is 50%. I will be going from here to 25 degrees Celsius, and then from here I will be going with a line having RH equal to 50%. The intersection will give me corresponding value of W. Tell me how much it should be. How much is Wi? Tell me. So all of you are seeing from a single mobile phone?
0.009.
You should bring the print copy of psychometric chart.
10 पे आ रहा है 9 10 पे
Sujal, you tell me the value. How we can do this? Tell me the process. Just now I have explained. What are you doing? You are sleeping in the class? Deepak calculated? If I want, I can quickly move on with all these questions, but I am trying so that you can practice actually. What is the value of Wi? Chirag calculated? Why you are not able to locate?
Sir, 0.0099.
0.0099241. Now, let me tell you one important point. See, sometimes for solving the question, what is required? Smart work. So how, what are these given conditions? If you are just paying any attention in the class, these conditions are corresponding to the previous problem. In the previous problem, just now I have given you the value. Okay, in the previous part, I have given this value using the saturated table. Here, just to explain the process, I have told you to calculate it from the psychometric chart so that we can go for the second method also. But for answering this question, this entire thing was not needed, because for answering the question, so Sujal, if you just pay attention, you can answer this question, because already in the previous, but you are not writing anything also. So it means the situation is clear that even if I give you the answer in front of you, then also you will not be able to do it. Okay, what to do next? What to do next? What will be RSH? Please tell me. You should be able to do it now. Tell me formula for RSH.
127.3 kilowatt.
कर्तव्य RSH formula. Sahil? RSH. Please tell me the formula. 0.00 एक जीरो हटा दूं. ओके 204 T T ADP. Okay, if zero bypass factor is there, then how much it is? 159.12 kilowatt. Calculated or not? What is RLH? Please tell me RLH. 50 into QVS. How much is RLH?
31.2 kilowatt.
30?
1.2.
No. Please tell me the RLH value. How much it is? 34.74. What will be RTH?
34.7.
What will be RTH? What will be RTH?
193.86.
How to calculate RTH? Tell me. 0.02 QVS HI minus HADP. How to calculate H? How to calculate H? Tell me, in the exam you people have to do this. Temperature is there. Okay, if temperature is there, how I can calculate H? Again two methods. Okay. If you are going for steam table, then three methods. You have located your state I and ADP here. From here you can directly read the enthalpy value. What is second approach? We have formula for enthalpy of moist air. How much is that? 1.005 into T plus W times 2500 plus 1.88 into T. From there I can calculate enthalpy. But that much is needed. What is room total load? RSH plus RLH. So just you need to add these two values. How much it is?
193.8. सर एक्चुअली जो हमने साइकोमेट्रिक चार्ट से WI की वैल्यू निकाली थी वो डालने पे 31.2 आ रहा है और आपकी वैल्यू में बस एक पॉइंट का फर्क है
ठीक है, it is
उससे
fine.
34 आ रहा है
Is this point clear or not? See, the point is, if you don't make notes, if you don't practice questions, you will not be able to do it. Even if it's a simple algebra is needed. Because you don't have practice, you have just kept your focus on a single formula, you will try to just do that only. So, the process which require only just addition, for that you will be doing one full page calculation and then later on you will say, sir, I have done this much, give me marks. So practice is needed. Okay, what is OASH? What is OASH? Outside air sensible heat. What should be the formula? See, sensible means 0.0204. Starting with that. Then, what I will be getting over here?
0.2 of QVS.
Yes. Into QV naught. QV naught is 0.2 of QVS. Multiplied by
45 minus
T naught minus
TI.
Ti. If you just refer to the previous lecture, we have derived these formulas. What will be OALH? 50 QV naught into and OATH will be what are the values? Tell me the values.
48.96.
48.96 kilowatt Next, correct? The only thing is, I also need to calculate outside air humidity. How to calculate W naught? How I can locate?
30% RH and 45%.
So I need to refer to 30% RH line and 45 degrees Celsius temperature. Corresponding to this, whatever point I will be getting, that will be representing my W naught. How much is W naught here? Anyone calculated? 0.018278. One eight two seven eight. Okay. Is this one clear? Now let us put a twist in this question. Till now, what assumption I made? Bypass factor was 1. Other than that, whatever volumetric flow rate is given, that volumetric flow rate is given for the indoor conditions. What are indoor conditions? 25 degrees Celsius and 50% RH. But in any case, what can happen? When this formula is valid, whatever the formula we are applying over here, this formula is valid when volumetric flow rate is available at which condition? STP. Okay. But particularly for room air, it's okay. My condition is close to the STP only. But for outside air, my condition of whatever the volume of air I am circulating, that is not at STP. What are the STP conditions? 1 bar, 25 degrees Celsius and 50% RH. Okay. So it means when I am applying this formula for room sensible heat factor, it is at STP condition only. My volumetric flow rate is at STP only. But when I apply this formula for QV naught, then this QV naught flow rate is corresponding to which condition? Yes. So in real practice, it is corresponding to outside air condition, and formula is derived for STP. So what I need to do, if I have to calculate correct value, I need to calculate the equivalent flow rate for the STP conditions. How to calculate that? I will try to calculate the specific volume of the ambient air. Okay. How I can calculate specific volume of ambient air? Please tell me. How to calculate specific volume of ambient air?
Divide by
For moist air, we generally follow the ideal gas equation. Okay. In ideal gas equation, P is equal to rho RT, and when I have total pressure, that is combination of rho RT for dry air plus rho RT for moisture. Temperature is same. So if I take rho A R A T common, I will be getting 1 plus rho W by rho A into, please tell me, RW by RA. So from here P will be becoming equal to rho A RA T times 1 plus rho W. If I multiply and divide with volume, what I will be getting? Mass of water vapor upon mass of dry air. So ultimately W times RW by RA. RW is how much? 0.462, RA is 0.287. So 0.462 upon 2.287, how much it is? 1.6078. Are you getting this value? So this equation I can 1 point.
So 0.482 by 0.287, 1.679.
1.679
Okay, so correct value would be probably slightly other than 46. So correct value will be 8.314 by 18. Is it correct? All are clear to this point? So maybe you have class. You have class? No class? Okay, so let me then complete this part. Okay, so from here, if I have any temperature and pressure corresponding to that, I can calculate the value of density. Is this point clear? So using this formula, if I try to calculate specific volume of air, then specific volume of air comes out to be specific volume of air comes out to be how much? What was the outdoor temperature?
45 degrees.
Okay, so if you calculate for that, how much will be VA? Please tell me. From here, can you calculate the VA? What will be VA? 1 divided by rho A. Pressure is 1.01 bar. R is 0.287 for dry air. T is 45 degrees Celsius. How much it will come? 312. 45, 538. 302. Okay, so it will be coming 302, and then W is given for outside air. I have just now calculated W naught. So tell me how much is VA, which is equal to 1 by rho. Please do it fast. How much it is?
Making 0163 volume.
0.0163.
0.88.
0.88, correct. So now if you calculate outside air total heat load, it can be simply given as 0.2 times m dot A, because just now mass fraction I am taking. So m dot A into H naught minus Hi, and it comes out to be 96.516 kilowatt, which was earlier how much? 99.0.